All right, here's the first question you sent me. It says, here's bivariate data set, which you believe y to be the response variables. We have x and y. Series of points. One point should really stick out to you. It should be this guy right here. This looks very different than the rest of the data. So we can assume that's the outlier, but we don't have to assume that. We can show that by graphing. So what I'm going to do first is I'm going to put all this data into my stat list. Stat edit. I'm going to put all the x into L1, all the y into L2. I'm going to pause the video real quick while I do that. Okay, so I have all the data in my L1 and L2. So if I want to make a scatter plot, the first thing I have to do is turn on the plot. So you'll see above the y equals button, there's blue stat plot. So I'm going to hit second y equals. I'm going to go to the first plot, plot 1. I'm going to turn that on. I want a scatter plot. That's this first option here. And the x values are coming from L1, y values are coming from L2. So once that's all good and set up, I'm going to hit zoom. And there's a statistics zoom that's going to show all my data. So if I hit zoom 9, it'll show all my data. So there's all the data. Oh, ignore that. Let me get rid of that graph. That's from a different class. Zoom 9. There's all the data. And believe it or not, there is the point we were talking about. Oh, let's see if we can get... Oh, I want to get rid of that other equation too. Excuse me. There we go. So this guy here is my outlier. Negative 157.7, negative 112.1. So they want you to list that. So that's just going to be the coordinate negative 157.7, comma, negative 112.1. Find the regression equation without the outlier. So I have to find the equation once I remove that data value from my list. Go back to lists, highlight the negative 112, just hit delete, it'll go away. Highlight the negative 157.7, hit delete, it'll go away. Now I want to calculate my regression. So I'm going to hit stat again, over to calculate. I want the linear regression, number 4. X values are L1, Y values are L2. You can enter through everything else. We don't need any of that stuff. So my equation is going to look like this. Y equals AX, which is 0.759. Let's see how many decimal points they want. Decimal places. 3 decimal places. 0.759 X plus 7.562. Okay, now let's just find the regression equation with the outlier. So I have to add that point back in. I'm going to go to edit. Just go down to the bottom of my list, and I can add the point. It doesn't have to be in order. This is negative 157.7, and this is negative 112.1. Whoops, that's a negative. Now I'll run the stat again. Calculate linear regression. Calculate. I want to see if it's drastically changed my equation. Y equals 7.759 9x plus 7.574. So when you compare these two equations, the slope's the exact same, and the y-intercept is very, very close to one another. So the outlier doesn't have a huge effect on my equation. So the outlier does not appear to be an influential point. It doesn't really have any effect on my equation. It falls in the same line as the rest of the data. Okay. This says a researcher wishes to examine the relationship between years of schooling completed and the number of pregnancies in young women. Her research discovers a linear relationship, and the least squares line is that, where x is the number of years of schooling completed and y is the number of pregnancies. This is an algebra problem. This is just y equals mx plus b. Here's your slope, negative 4. Every time x goes up, y is going to go down by 4. X is the number of years of schooling. Y is the number of pregnancies. So when schooling increases by 1 year, the pregnancies decrease by 4. When the amount of schooling increases by 1 year, the number of pregnancies decreases by 4. Okay. This is the same thing we just did. I'm just going to put this data into my stat list. I'm going to clear out what's in there. Go up to L2, hit clear, enter. Go up to L1, hit clear, enter. I'll do this. Let me pause this again because it's going to take a little bit. So I have my data in L1 and L2. Go back to stat, calculate linear regression. Calculate. So it's very pretty. I just have y equals 8x plus 11. That's it. And the last one, it says an experiment is run, the mass of an object is recorded over time. You're just going to plot these points. These are all x, y points, or t, m points. 1845, 18, comma 45. It's right here. 19, comma 32 is right here. Doesn't have to be exact. It's 18, comma 45 right there, something like that. 29, comma 24, 29, comma 24 right there. 39, 22, 39, 22 right about there. 48, 18, 48, 18 right about there. That's all you're doing for the first part. And then it says use the calculator to find the linear regression again. So we'll go back to stat, edit our lists, clear them out. 18, 19, 29, 39, 48, 45, 32, 24, 22, and 18. Go back to stat, calculate linear regression, enter through all this. My linear regression is 2 decimal places, so that's going to be y equals negative 0.72 plus 50.08. Oops, 0.8. And that's it. That's all you're doing this whole chapter pretty much.